Hi, my name is Deswitat, number matrix C190240, and I will present about the Lab 4 5.1 and also the 5.2. First of all, this is a 5.1 which is latching relay. So, as you can see, this is our PV start, and S1 this is our PV stop, and this is a relay, and also the output. Okay, first of all, we deactivate the push button and you will get all the output. Okay, but we activate this PB stop and you will get nothing. You will disable all the output. Now is for the question 5.2. So first of all, this is the robot output, and this is a sensor for the detect someone across the yellow line, and this is a siren. Okay, then we start one. See this, and you will get the output since we start to function our robot. When somebody has across the yellow line, so the robot will stop and you will activate the siren here. So how do we deactivate our siren, which is when has the sensor is not detect somebody, and then we off. So we click the reset button here. And now you will turn off the siren and continue run the robot. That's all for the question 5.2. Thank you.
Case Doctor and Vinny, metric number AE190104. Now I will start to design the data diagram of question 5.3. So the network 1 will have two open contact in parallel and the normally closed contact and one output relay. While in the network 2 we'll have the output relay in network 1 as our input contact at here and the gauge door as our output. Then we rename all of them and compile. Check the error. Okay. Now open the COMMGR. Start. Now we can turn on the online mode and click on transfer. Then run it. We can see here when X1 detect the approaching car, X1 will turn on. Then the M1 will be activated and turn on the Y0. If the X1 does not detect the approaching car, means that we turn off the X1, the M1 and Y0 will remain on until the X2 detect the whole body of car has safety parked inside the gauge door. Then the Y0 will only turn off. However, once the X2 is activated, it will cause the circuit to break and the power to be cut. So that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nonisha Binti Abu Bakar and my metric number is C102222. I will answer question 6.0. In this question, we need to on the sensor to put the apple on the box. If the apple is counted to 10, the conveyor is stopped. So for this program, we use counter. Firstly, we need to create the program like this. And we must to make sure that the component is right. And MO is latching relay. Then turn on the online mode. and we run it. After that, we click the S1 until the counter count to 10. And here, the C0 is on, but the Y1 is off. So, here we need to turn on the M0 to on. So, we set on and the Y1 on. In network 2, M0 is at like power and Y1 is like switch. So that's all from me and thank you.
Okay, Assalamualaikum. For the discussion, when the call power is switched off, latching relays are designed to keep the relay closed. The conventional relay logic open the contact as soon as the call is freed. When contact must remain open or closed even if the coil is only energized for a short length of time. Latching relay are utilized. The program element that have been classified as latching relays will remain on once triggered. Only relays and output can be assigned to latching relays. In many circumstances, even when the input is shut off, it will vital to keep an output powered. A simple example of this is a motor that is started by pressing a push button switch. The motor must continue to run until a stop push button switch is activated since the switch connection are not closed. The circuit that performs this activity is known as a latch circuit. It's a self-maintaining circuit since it maintains its state after being powered up until another input is received. Okay, next for the conclusion. Finally, thanks to this lab, we will able to learn how to use latching relays in PLC programs. Aside from that, we are now familiar with the many PLC programming techniques available in ISP soft such as counter and timer. Finally, as a result of all of previous lab, we can now write, run and troubleshoot our own simple PLC programs that are specific to the task at hand. Okay, that's all from us. Thank you.